All right, so today I'm just going to be doing a few lessons on how to approach word problems that involve integrals when they're combined with net change and rate of change. So, the first question that we're looking at is this question about an empty tank that has a capacity of 1,000 liters. The first thing I will always tell people when answering word problems is simply read the problem. Don't write anything down, don't try solving anything. Simply read the question. So, an empty tank has a capacity of 1,000 liters. Water is pumped into the tank at a rate of 60 minus t liters per minute, where the time t is measured in minutes. How long will it take to fill the tank to its full capacity? So, in this question, it is simply asking us to find t when the water level in the tank has reached 1,000 liters. So all this question is asking us is, in this tank, the water level originally has a position of 0 because there's no water in there. And all it wants us to find is how long does it take for the water to reach the top at 1,000. It is asking us how long it took to go from 0 to 1,000. Now, this question has already given us the rate of change for this water. The water flows into this empty tank at 60 minus t liters per minute. And we already know that the maximum capacity of this tank is 1,000 liters. So think of this as a rate of change, as we know, is simply a derivative. And we already know that the position of the water is going from 0 to 1,000. So what is the derivative of a position equation? It is a velocity equation. So what we can infer is that 60 minus t is equal to the velocity equation. And we are going to look for s of t, the position equation. Now this is where the use of integrals comes in handy. So we already know that since velocity is the derivative of the position equation, we also know that the integral of the velocity formula would be equal to the position equation. So what we're going to do is we're simply going to take the integral of the position formula, which in this case is 60 minus t. Now, this is a very simple integral, but I will still compute it for all of you guys. So, let's do this. The integral of 60 minus t with respects to t. Now, we are simply just going to use the power rule twice. One for the 60 and one for the minus t. So 60 can also be seen as 60 times t to the 0. So in this case, all we're going to do is we're going to do 60 t to the 1, so we don't have to write that down, over 1. And we know that for this power rule, this is equal to t to the 1. So we're going to simply add 1 to that and divide by this 1 plus 1. So this turns into t squared over 2 because we have 1 plus 1. And then finally plus c because we have no idea what constant may have been added to the end of this equation. This can simply be rewritten as 60t minus 1/2 t squared plus c. So before we can do anything else, we have to find out what this plus c is. And a lot of people get stuck at this step because they don't know how to find that plus c. But There's a very crucial piece of information in this question, which most people don't notice because they don't read the question first. They immediately jump into solving. And that is that this is an empty tank. This means that at t equals 0, S of t also equals 0. And what we can do here is we can set this equation right here equal to 0. So we can so S of t is 0, so 0 is equal to 60 times 0, because at this point in time, we haven't started filling this tank with water yet. So we do that for the other one as well. So you end up with 60 times 0 minus 1/2 times 0 squared plus c. And with this, we find out that c is equal to 0. So we can rewrite this position equation right here as S of t is equal to 60t minus 1/2 t squared. Now that we have the position equation without any plus c's or any other variables other than t, we can now attempt to solve for t when there is 1,000 liters of water within this tank. So we replace S of t with 1,000 because this tank goes from 0, which is its original position, to 1,000. So we get 1,000 is equal to 60t minus 1/2 t squared. Now, when faced with such an equation, I usually prefer to get rid of any fractions before we move on, mainly because this is a quadratic, meaning we most likely will either have to factor or use the quadratic equation. And this can get very annoying if there's fractions within our question. So I'm just going to multiply everything by 2 so we can get rid of that fraction. So we end up with 2,000 is equal to 120t minus t squared. And now this is not going to be something I can factor very easily without a calculator. So I'm simply going to use the quadratic formula instead, because this is something that is not very nice to factor. So I'm going to move everything on the right side over to the left side because I want that t squared term to be positive. So I ultimately end up with t squared minus 120t plus 2,000 is equal to 0. And from there, I'm simply going to use the quadratic equation in order to get two possible values of t. Now, I'm going to let you guys do this at home because I don't have a calculator on me currently, but I will write down this equation for you. Quadratic formula is something that is very, very nice to know, so I always recommend you completely memorize this one. Now, once you do this, you end up with two potential values. You should end up with t equals 20 and t equals 120. Now, which of these answers is correct? Now, this is unfortunately not a question where one of these values is negative, where we could immediately get rid of it, but this is where our rate of change equation comes in again. So, because we know that water is only pumped into the tank and not out of the tank, we know that the rate of change must always be positive. So, we know that 60 minus t has to be greater than 0. And simply from plugging in both of these values in for t, we find out that t equals 120 would make this below 0. So therefore, the correct answer is t equals 20. And because t is measured in minutes, this has the unit of minutes. And whenever you solve a word problem, it is always recommended to write a therefore statement. So, therefore, the time it takes for the empty tank to fill up is 20 minutes. That is how we answer this first question. Now, take a second. If you don't understand how everything was done, go back to a certain part of the video and make sure you understand this, because our next problem is going to be slightly different, and we're going to approach it in a different way. So I'm just going to stay here for a second so that you can fully process everything, and then we'll move to the second question. All right. So once again, before we look at any numbers or look at how to solve this question, we're simply going to read it. So, a sanctuary of wolves was funded with 1,000 specimens. The population grows at a rate of wolves per year described by the function 50 times e to the 0.05 t, where t represents years. How many wolves will be in this sanctuary after 10 years? So, this is once again another question where we're provided with a rate of change and we're asked to find a certain value. The only difference is in the previous question, we were given an amount and we were asked to find, using the rate of change equation, when the position equation would equal that amount. But in this case, we're already given a time period, which is 10 years, and we're asked to find out how many wolves there are after those 10 years using this rate of change equation where t is in years. So, what we already know is rate of change, once again, is going to be a derivative value of the position equation. So what we want to find is the position equation. So we are once again going to take the integral of this rate of change in order to find an equation that helps us find how many wolves there are in a certain year. Now, for those of you who don't understand why we're taking the integral here, I'll explain it like this. So we always know that the rate of change is how fast something changes over time, otherwise known as the slope, or in this case, a derivative. Now, we don't want a rate of change. We want an equation that helps us find how many of something there is, which, as you'll notice, is going to be very similar to a position equation, because a standard position equation tells us how much, how far, how many, or it helps you find out the total amount of something after either a certain period of time or after a certain thing, or when a variable equals a value. So, what we're going to do in this case is we have the rate of change, which we usually denote as v of t. T because this is time, and that's what the t represents. So we know that v of t is equal to 50 e to the 0.05 t. Now, we want to find the position equation for this rate of change equation. So what are we going to do? We are going to take the integral of it. The integral of 50 e to the 0.05 t. Now, a very easy way to break up this integral is through removing the constant. So we're just going to bring the constant of 50 outside of the integral. And when we do that, we get an integral of e to the 0.05t. And I forgot this in the original one, but it is in respects to t. So we're just going to have dt at the end of this equation. Now, how do we take the integral of this? Well, there is a formula for taking the integral of an exponential raised to a constant and a variable. Now, for those of you who don't know what an exponential is, it is simply a function which has e as a base, which is raised to a variable. So e to the x. So this formula states that the integral of e to the constant x is going to be equal to 1 over k e to the kx. Now, this is a very simple formula and is a very good one to know. So I would recommend everybody memorize this, but for the time being, we are simply going to take the integral of this exponential. So we're going to have 50 times. So the integral of e to the 0.05t is simply going to be 1 over 0.05, because that is our constant value, times e to the 0.05t plus c. Because once again, we have no idea what constant may have been in front of this equation. Now, something I usually like to do is, if because I removed this constant previously, I'm going to multiply it in. And I end up with 50 over 0.05 e to the 0.05t plus c, which very, very nicely ends up simplifying, because 50 divided by 0.05 is simply equal to 1,000. So 1,000 e to the 0.05 t plus c. Now, once again, as some of you may have already noticed, we have to remove that plus c from our equation, because we don't want any other variables other than t in this equation. So, how do we do this? Well, what we very obviously know is when this sanctuary of wolves started, it was originally funded with 1,000 specimens. This means that when t equals 0, specimens, or you could just say in this case that s of t when t equals 0 was 1,000. So what we can do here is we can simply set our position equation, which is currently 1,000 e to the 0.05t plus c equal to 1,000. And we have to set t in this case equal to 0. And when that happens, this simplifies to e to the 0, which is going to be 1. So 1,000 plus c is equal to 1,000. And for this to work, you finally end up with c is equal to 0. Now, this is a very lucky and coincidental question where c is 0, but there will be some times where c is not equal to 0. For example, if the initial starting amount happened to be, let's say, 995, then c in this case would be equal to 5. But because we had 1,000, and this is a very nice question, c is going to simply be equal to 0. And from there on, we can write our position equation out as s of t equaling to 1,000 e to the 0.05 t. Now is the very easy part. We simply just sub in values and use our calculator because the numbers are very big. You will never be expected to calculate something like this in your heads without a calculator. You will always be either given very nice numbers or you will be given a base other than e, in which case the integration would be different as well. But for this question, we have all we're going to do right now is we're going to sub in 10 for t. So s of t is equal to 1000 e to the 0.05 times 10. Now, I don't need a calculator for this, but 0.05 times 10 is simply 0.5. Yep. And once we plug that into our calculator, and allow me just 1 second to get a calculator really quickly, we shall end up with e to the 0.0 e to the 0.5 times 1000. We end up with that being 1648.7 wolves. Why wolves? Because the rate of change is wolves per year, and T represents years. So once you get rid of that, there is going to simply be 1648.7 wolves. Now, when it comes to people or animals, I do usually like to either round up or down to the nearest item or person. So, in this case, I'm going to simply round up and say there is going to be 1649 wolves. The reason I will round up in this case, up or down, is you can never have zero point 0.7 of a person or an animal. It is possible to have zero point 0.7 of an object, but you cannot have zero point 0.7 of a person or an animal. And once again, we're going to write our therefore statement because we should always do one for a word problem. So, therefore, after 10 years, now whether you use the number or the word, it doesn't really matter, but after 10 years, there will be 1649 wolves within the sanctuary. And that is how we solve this question. So, I hope you have gotten a general idea of how to approach these questions, but if you haven't, I'll just give you a quick summary once again. Whenever you get one of these questions, always just read the question. Take a little bit of time, read the question, and fully digest what it's asking you. After that, either highlight or underline any important information that may help you solve this question. And then finally, figure out what your original equation is, what it's asking you to find, whether it wants you to find a rate of change, an original equation of how many, or a position equation, an acceleration. No matter what it wants you to find, you are equipped with how to solve it. Otherwise, you would not be given this question. So that is it for today. And if you have any other questions, let me know.